Good day everyone. Today let us see one new model. I am going to compare two types and then I will teach you. To find the foot of the perpendicular, the length of the perpendicular and image from a point to a given line and from a point to a given plane. These are the two things I am going to compare and teach you. Now look at the sum here. You have to find the foot of the perpendicular, length of the perpendicular and image from P2, 4, minus 1 to the line. X plus 5 by 1 is equal to y plus 3 by 4 is equal to 6 minus z by 9. So here, see this figure. AB is the given line, the equation you know. P is the given point, 2, 4, minus 1. Q is the foot of the perpendicular and R is the image. You are going to find Q. You are going to find the distance PQ. You are going to find the coordinates of R. Okay? Coming to this sum, you find the foot of the perpendicular, length of the perpendicular and image from P3, 2, 1 to the plane 2x minus y plus z plus 1 is equal to 0. A plane is represented as a parallelogram always and P is the given point, Q is the foot of the perpendicular and R is the image. Here also you are going to find the same three, that is the foot and the length and the image. Okay. So now here the equation of line AB, this part alone is not in standard form. So let me write it properly. So equation of the line AB is, I will write x plus 5 by 1. That is equal to y plus 3 by 4. I will take a minus out and bring it to the denominator. So z minus 6 by minus 9, I will equate it to some constant k. Because I want to find any general point on this line, I am equating it to some constant k. Now, any point on AB will have coordinates. Okay? Any point on AB will have coordinates. How I am going to find? I will take these two. X plus 5 by 1 is equal to k. So the x will be 1 into k. Then plus 5 will become minus 5. So the x coordinate will be k minus 5. Similarly, the y coordinate will be 4k minus 3. The z coordinate will be minus 9k plus 6. So any point means Q is also a point on AB. So I can say that Q is k minus 5, 4k minus 3, minus 9k plus 6. This is one important step because this is Q. So I mark it as 1 here. Right? So now I am going to use the concept. The lines AB and PQ are perpendicular. If two lines are perpendicular, you know, the sum of the product of the DRs is equal to 0. So that concept I will use to find the value of K. Once I find K, the rest is easy for me. So now I will write DRs of the line AB. Okay? DRs of the line AB. Check the equation. You can write from the denominator 1, 4 and minus 9. Now, DRs of the line PQ. You know the point P. You know the point Q. When you know 2 points, the way to find direction ratios is x2 minus x1, y2 minus y1 and z2 minus z1. So now k minus 5 minus 2. So I will get k minus 7. 4k minus 3 minus 4. I will get 4k minus 7. Minus 9k plus 6 minus of minus 1. So I will get minus 9k plus 7. So these are the direction ratios of the line PQ. Now I told you already AB and PQ are perpendicular. Okay. So the sum of the product of the DRs is equal to 0. I am going to find the value of K. I think up to that I will do so that stage I will reach. So now I know the DRs. So I will now proceed to the sum of the product of the DRs is equal to 0. I will proceed to that one. Okay. So now the sum of the product of the DRs is equal to, DR means direction ratio, okay, is equal to 0. So now let me do 1 into k minus 7, that is k minus 7, plus 4 into 4k minus 7 minus 9 into minus 9k plus 7, that is equal to 0. Let us expand. So we will get k minus 7 plus 16k minus 28 plus 81k minus 63 is equal to 0. Collect the k terms. 81, 1 and 16. Okay, 81 plus 1, 82 plus 16 is 98k. 28 plus 7 and 63, everything is in minus. So minus 98 is equal to 0. So I will get k is equal to 1. So here I have used the concept, the two lines are perpendicular, therefore sum of the product of the drs is equal to 0. I found the value of k. Let me stop. That is one stage for me, right? Now let me come to this one here. Here, because this PQ is perpendicular to the plane, PQ is a normal to the plane, right? PQ is a normal to the plane 2x minus y plus z plus 1 is equal to 0. So now, when that is the normal, you can easily find the direction ratios. So I will write drs of PQ are 2, minus 1, 1. Correct? Now, you know the point P. You know the drs. You can write the equation of the line PQ. So, equation of the line PQ is x minus 3 by 2. You remember x minus x1 by a, that one. Okay? That is equal to y minus 2 by minus 1, that is equal to z minus 1 by 1. When you get the line equation, let me equate it to some constant lambda. So now I can get any point on this line will have coordinates. Okay. So any point on line PQ will have coordinates. The same way as we have done there, here we will find 2 lambda plus 3, minus lambda plus 2, lambda plus 1. Okay. Now, Q is also a point on the line PQ. So, I can write Q is 2 lambda plus 3 minus lambda plus 2 and lambda plus 1. Now, I am going to use the concept. Now, the Q, that point, that is the foot of the perpendicular, lies in the plane. That is the concept we are going to use. Now, Q lies in the plane 2x minus y plus z plus 1 is equal to 0. So, now you are going to substitute this coordinates in the place of x, y, z to get the value of k. So, that is the difference between these two. Okay. What concept you are using there and what concept you are using here, you should be clear. So, now to find k, I am now going to use this one. So, now 2 into 2 lambda plus 3, then minus 1 into, I will get minus lambda plus 2, then plus 1 into, I will get lambda plus 1. Okay, then write this plus 1, don't forget it. Plus 1 is equal to 0. You have to take the full equation. So, now I will get 4 lambda plus 6 plus lambda minus 2 plus lambda plus 1, so that is plus 2, that is equal to 0. So, this minus 2 and plus 2 will go. I will get 4 lambda plus lambda, so 6 lambda plus 6 is equal to 0 or lambda is equal to minus 1. So, in both the sums, we have found the value of that constant. Here I got k, here I got lambda. So, this is one stage where I have reached. Now, it will be very easy for us to proceed further. Okay. So, now I know k. From that, first I will find the foot of the perpendicular. That is my main point now. So, I know q. So, I will substitute the value of k in this q. So, now I will get q is, k is 1. So, I will get minus 4. 4 into 1, 4. 4 minus 3 is 1. Okay. Minus 9 plus 6. So, minus 3. So, I got the foot of the perpendicular answer. This is one answer for me. Let me mark it as 2. Then to find the length of the perpendicular, you know P, you know Q. Just use the distance formula. Root of x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. You can find the length of the perpendicular PQ. So PQ is equal to root of, now P is 2, this is minus 4. You can take anything as x1, y1, z1. So I am taking this 2 minus of minus 4. So 6 squared plus 4 minus 1. So 3 squared. Okay, plus minus 1, that will become plus 3. So 2 square, that will be, I will get root 36 plus 9 plus 4. So I will get 49. So I will get 7 units. This is the length of the perpendicular. Okay, so once you find that K, then things are very easy for you. So now to find the image, what is the concept we are going to use? See here, if you look at, I will just draw this line. This is P, this is Q, this is R. Q will be the midpoint of PR. Okay, so now I know P, that is 2, 4, minus 1. I have found now Q. Q is minus 4, 1, minus 3. Or let me take it as some x, y, z. Use the midpoint formula. You know the midpoint formula, x1 plus x2 by 2, y1 plus y2 by 2, z1 plus z2 by 2. So I can write now minus 4 is equal to x plus 2 by 2. So that gives me x is equal to minus 8 minus 2, that is minus 10. Okay. Then for y I will get 1 is equal to y plus 4 by 2. So y plus 4 is 2. So y will become now minus 2. Then for z I will get minus 3 is equal to z minus 1 by 2. So z minus 1 is minus 6. So my z will be minus 5. So now my image will be minus 10, minus 2, minus 5. So we have got all the three answers. You have found the foot of the perpendicular, you found the length of the perpendicular, and then you have found the image also. You give the image also in the Cartesian coordinate form. So now this is over. Now here we have found the lambda value, right? Now the same way, no change at all. Once you know that, you know Q. So you can substitute there the lambda value to get your Q. Now the Q is, lambda is minus 1. 2 into minus 1 is minus 2. So I will get 1. Minus 1. Minus 1 into minus 1 is plus 1. So I will get 3. Here minus 1 plus 1, it is 0. So this is the foot of the perpendicular, right? Now you use the distance formula. You can find yourself the distance PQ, correct? Use the midpoint formula. As you use that, you will get the image also. So now the comparison, I think that would have made things clear to you. So just I will say the main concepts once again as a recapitulation. So here first AB equation, you know that you are equating it to some k. You find any point on the line will have some coordinates. That you take it as Q. Then you find the drs of the line AB. You find drs of the line PQ. Then the sum of the product of the drs is equal to 0. You find the value of k. After that, you are using the distance formula. You are using the midpoint formula to find the length as well as the image, right? Here the concept is, you are taking PQ is a normal to the plane. Therefore, you know the drs of PQ. You know the point P. You write the equation of the line PQ. Then you find any general point on the line PQ. You equate it to some lambda. You get Q in terms of lambda. The Q lies in the plane. Use that and then evaluate lambda. Once you know lambda, you know the foot of the perpendicular you can find. Then distance formula, then midpoint formula. I think hope you are clear about the two models now simultaneously. Thanks for watching the video. You can subscribe to the channel and you can click the bell icon to get notification of further videos.